Hello. What's it all mean? There we go. All right. So we are particularly interested in inverses, and in order for a function to have an inverse, it must be one to one. And likewise, in order to be an inverse, the function must be one to one. All right. Also note the inverse notation that we're using in context of the function notation. It means inverse, does not mean reciprocal. So 1 divided by is not what's happening here. Be careful about interpreting new things exactly the way other things are. They're not always the same. Alrighty, so the basic idea of a function and its inverse is that the input output just change roles. So we've got the function domain and the inverse domain. So the inverse domain is the function range. And basically, for this table, the corners just are the same, like that. So we've started with the function of the domain. That's the range of the inverse. They just switch out like that. All right. And then similarly for points, but it's going to be the x and y specifically switching, which is exactly what we did. Domain is x and range is y, like that. So the function, we've got that point. You switch it out for the inverse, likewise for the next one. And the last one, we're given the point on the inverse, and the x and y just swap out. All right, let's take a look at graphing. And way back, whenever transformations, I said if you're graphing anything with a curve, pick several points, and I've labeled 4 with the little dots here to make them easy to see. They may not always be labeled with the dots or labeled with the point notation, but they are going to be obviously through the corner of the grid. So pick a couple, however many. I got 4 to capture that curvature. Now, one of the things about this particular graph that we've not really seen before is on the left side of this graph, it looks like it's leveling out at y equals 3, and it is. So that's a horizontal asymptote. And similarly with the points switching x and y, this graph has a horizontal asymptote. The inverse will have a vertical asymptote, like that. So let's do our table. There are the points that are marked and the horizontal asymptote at the bottom. And for the inverse, we switch those out, including the horizontal asymptote becomes a vertical asymptote there. Plot the points, plot the asymptote, connect the dots. There you go. That's how you graph the inverse.